Hey there. We're going to do a little podcast today on science, measurements, uncertainty, and error. All the labs that we do in science class are going to involve some degree of error. But it's important for us to understand the different types of error and how we can deal with error during lab work and how we can try to minimize error as much as possible. So no matter what, there's going to be some mistakes that happen. When we make measurements in class, we said let's estimate one digit beyond the smallest marking. There's some uncertainty with that estimated digit. We can all measure the mass and the volume of the same object, and we're going to rarely get the exact same results. So they're always going to be somewhat different from the true value that we actually should get. And these deviations that we see are what we call errors. So in science, we're going to deal with errors, and we're going to be able to address them typically at the end of the experiment and be able to have a discussion about why there was error and how we can handle the error. In designing the experiment, it's important to try to come up with a list of variables that we can control so we can minimize as many errors as possible. But no matter what, there will be errors that we deal with. And there's two types of errors that I would like to discuss today: random errors and systematic errors. So random errors are always going to be present. There's no way around it. As much as we try to control an experiment, there will always be some type of error that makes something different from the actual number that we're trying to find. And so when we do this, we can statistically analyze our results to see how close we were to each other. That's why it's important when we do experiments to take many trials, repeat your measurements over and over again, and calculate the average or the mathematical mean. So once we do that, that can show us how spread out our data is. So if this was the actual data, the distribution of X with no random error, and we plot it against the data that was actually collected, we can see there's some discrepancy. So this random error could be a result of operator error. It could be a result of changes in experimental conditions. So doing a trial on one day and then coming back and doing a trial on another day. Maybe the degradation of the chemicals that we were using. There's so many different variables that we will learn to discuss and be able to recognize as a result of just these random errors. So systematic errors, again, are typically present. We want to make sure that we minimize them as much as possible, and we can minimize the systematic errors when we design and develop the experiment. So this can be a result of the instrument that we are using. So if we're calculating the pH of a solution and the student did not calibrate their pH probe correctly, that could just be that their numbers are off in a certain direction. So if we know that this is what we are supposed to get and this is what we ended up measuring for the pH, well, probably they didn't re-zero their pH probe or calibrate it correctly. Or if your electronic balance was automatically off by 0.5 of a gram, that's going to skew all of your data one way or the other. So this can create what we call bias. So the systematic error doesn't always affect the average, but it does bias the data and it shifts what we expect to happen one way or the other from the average. So again, we can minimize this to make sure that our equipment that we use is finely calibrated. We can make sure that we're using the best possible techniques. If you're asked to measure 1 milliliter of a liquid, instead of using a 50 milliliter graduated cylinder, you might want to use a transfer pipette that only can measure up to 1 milliliter. So the precision of the equipment can definitely help minimize systematic errors. So we've already learned the concepts of making precise and accurate measurements. So the precision and the accuracy we know is limited based upon the equipment that we use. And the more precise we can be, because we're using equipment that is necessary to conduct the experiment, we'll make sure that our data is more reliable. And again, accuracy deals with how close we actually are to the actual number. So when we find the results of an experiment, we also want to make sure that we can identify the errors and how big the error was. So when we do this, we can minimize it the next time, because very often we will conduct an experiment and maybe we got data that didn't agree with what we should have got. So what we can do is we can reduce the magnitude of the error by redoing the experiment, maybe changing the type of equipment that we used. We could redesign the experiment, or we could even collect more data. So no matter how good you are, there's always going to be error. It just happens. But we need to be able to deal with the error, know how to address it, and know how to discuss it when we do a lab report. And ultimately, one of the things that we can do to discuss the error associated with the lab is by doing statistics. So we will spend some time in this class making